So this question was sent to me via a student about a function being one-to-one. So the question becomes, what does it mean for a function to be one-to-one? So if a function is one-to-one, it means it passes the horizontal line test, which tells us there is an inverse that is a function as well. So I can't really draw on this graph, so I'm going to pull up a little paintbrush. And I'm just going to sketch this graph so you can see what I'm talking about here. So let's just say we have this, which is very similar to the question that we just asked, right? So to tell if a function is one-to-one, it's the opposite of the vertical line test. It's actually a horizontal line test. So if I draw a horizontal line, if it crosses one time, so it crosses once, crosses once, crosses once, crosses once, then it is one-to-one. So an example of a function that would not be one-to-one would be something like a parabola. So if I have a parabola and I draw a horizontal line, it touches twice, which means that it's not one-to-one. And what is the significance of that? If it is not one-to-one, then it doesn't have an inverse for this course. Okay, the actual correct mathematical language is that its inverse is not a function. However, for the purpose of the lab, what it's asking you is, if it is, graph its inverse. So we're kind of assuming if it's not a function, the inverse is not a function, we're not as interested in it. So how are we going to graph this using this grapher? So this is what I did. So I zoomed in pretty far so that I could get 2 points. So I want to select points that are on an easily identifiable corner of the graph. So if I look here, I have a point at 1, 1, right? So if I have the point 1, 1, an inverse is switching the x and the y value. So the inverse of 1, 1 is still going to be 1, 1. So using my grapher tool, which I don't have as an instructor, but utilizing the grapher tool, you're going to put a point at 1, 1. Now you need to find a second point somewhere on the graph that crosses at one of these pretty nice corners. So this is the point 2, let's see, 1, 2, 3, 4, 5, 6, 7. So the point 2, 7, 2 on the x-axis, 7 on the y-axis. And remember, to graph in the lab, all you need is 2 points, okay? That's the significance of what I'm doing here. Once I have 2 points, I'm able to do this. So if I have the point 2, 7, the inverse is switching the x and the y, so it's 7, 2. So utilizing my graphing tools in the math lab, I'm going to plot 1, 1 and 7, 2 and connect the line between them to get my inverse. So I have 1, 1, 2, 3, 4, 5, 6, 7. So the inverse graph would look something like this for that graph. Something like that. So all you're doing here is applying the horizontal line test. So I'm drawing my horizontal line test to know if it's one-to-one. And then to graph the inverse function, you want to find 2 points that fall on the corner of a square so that I can utilize that. I hope that's been helpful for you guys and that you're able to do this question in the lab.